Okay, so we are looking at the guided notes again. Hopefully we can minimize the glare this time. So we are going to start with some definitions and some just general items. A dilation is a transformation that changes the size of a figure. It can become larger or smaller, but the shape of the figure does not change. Dilations have a center of origin, center of dilation, which is usually the origin, and a scale factor. If the scale factor is k greater than 1, then the dilation is an enlargement. If the scale factor is less than 1, but greater than 0, then the dilation is a reduction. If k is negative 1, then there's going to be some rotation of 180 degrees happening as well. Okay, let's go ahead and look at our first example here. It says, graph the image of rectangle JKLN after a dilation with a scale factor of 5 centered at the origin. So first of all, we're going to find the original coordinates. So the original coordinate of M is negative 2, 2. The original coordinate of L is 2, 2. And the original coordinate of J is negative 2, 1, negative 1. And the original coordinate of K is 2, negative 1. Apply the function f of xy transforms 5x, 5y. Really simply put, we're just going to multiply everything by 5. So we had negative 2, 2 multiplies to become negative 10, 10. 2, 2 multiplies to 10, 10. Negative 2, 1 multiplies to negative 10, negative 5. And k multiplies to be 10, negative 5. If I plot the updated coordinates, negative 10, 10 goes in this very top corner here. We have L goes in this top corner here. And then we have J goes right here. And K goes here. And if I were to connect these together with some beautiful lines, it would look something like this. Okay, let's go ahead and move on. Most of you guys will find these to be pretty simple and straightforward. It's the reductions that are going to be more of a challenge for you. So over here I have a little note. Enlargements are usually easier than reductions. When you reduce, you usually have to either multiply fractions or convert to division. So say I was trying to get, here's a sample problem. Say I was trying to get half of 4. So you could either do 1/2 times 4, or you could just do 4 divided by 2. Either way, this answer right here is going to be 2. Over here, I'm asking what 1/5 of 20 is, or think of it as 20 divided by 5. That's 4. If I have 1/4 of negative 8, that's the same as 8 divided by negative 4, or I could just call it negative 2. 2/3 of negative 12, I'll try to break this one down a little bit more for you. So you've got 2/3 times negative 12. The best way to think about this is 3 goes into negative 12, negative 4 times, and then you do 2 times negative 4 is negative 8. So that would go to that one right there. 4/3 of 6, same thing. I'm going to kind of break it down. 3 goes into 6 2 times, and 4 times 2 is 8. 3/2 of 18 would be 2 goes into 18 9 times, and 3 times 9 is 27. Not, incredibly complex stuff, but I realize that some people have issues with multiplying fractions. Okay, last example we're going to look at together is a reduction. So It's a dilation. The scale factor is greater than 0, but it's less than 1 because it's 1/2. So this will be a reduction. Okay, first step always on transformations is to find your original coordinates. So this is -8, 8. This right here, D, is going to be 10, 8. B is going to be -10, -10. And C is going to be 10, -10. Okay, so in the small writing, you're going to see that you apply the function 1/2 x, 1/2 y. And it looks like I have an extra parenthesis in there somewhere. Okay, so that's the same thing as taking half of all of these numbers. So fortunately, they're all even numbers, so they can all divide by 2. So if I take half of -8 and 8, I end up with -4 and 4. I don't think that's a -8. I think that's a +8. If I take half of 10 and 8, I'm going to get 5 and 4. If I take half of -10 and -10, I get -5, -5. If I take half of 10 and -10, I get 5, -5. Only thing left to do now is to plot my points and connect them together. So this is -4, +4 goes right here, and then 5, 4 goes right here. And then we're going to do -5, -5 goes to this corner right here. And then we have 5, -5 connecting together the rest of the trapezoid. So it looks roughly like that right there. All right, try to make your drawings a little bit neater. Use a ruler even maybe. All right, so I'll leave you with the last little section on here is independent practice. And if it helps, this is 3/2, and this is 5/2. But it might help just to multiply with the decimals. All right, good luck.